Okay, so our topic is the soil bearing capacity for shallow foundations for Terzaghi bearing capacity equations under local shear failure. So for our local shear failure equations, so for a strip footing, so strip, long, or continuous, we have our QU as C and C plus Q and Q plus 1/2 B gamma and gamma. For our square foundation, so we have QU as 1.3 C and C plus Q and Q plus 0.4 B gamma and gamma. And for our circular foundation, QU is equal to 1.3 C and C plus Q and Q plus 0.3 B gamma and gamma. So the equations are the same with our general shear failure equations, but as noted, for our QU, instead of QU, that will be QU prime. For our bearing capacity factors, instead of just NC, NQ, and N gamma, it will be NC prime, NQ prime, and N gamma prime. So for these modified bearing capacity factors, it was already modified under the condition it must be tangent of phi prime bar, which is already converted to 2/3 of the tangent of phi prime. So the converted values are already shown in table 2.2. On the other hand, for our cohesion, so for the three different equations, our C prime turns out to be C prime bar, wherein the C prime bar is the reduced C prime reduced to about 2/3 of the original cohesion. Again, take note that for the local shear failure, it is under the medium dense. So for the general shear, it is the dense soil. So dense soil is stronger than a medium dense soil. The following are the different values of our NC, NQ, and N gamma prime. So which are the Terzaghi modified bearing capacity factors intended for the local shear failure equations. So let's take now our sample problem. So a 1 meter square footing carries a total load including its own weight of about 60,250 kilograms. The depth of the footing base is 1 meter below the ground surface. So the average density of the clay soil is 1,850 kilograms per cubic meter. Cohesion is 15 kilopascals and angle of internal friction as 20 degrees. So determine the gross foundation pressure or Q allowable. For B, the overburden pressure, the effective stress, or otherwise our Q. So for C, the ultimate bearing capacity of the soil, Q sub U. And D, the ultimate bearing capacity assuming local shear failure, QU prime. So take note that if ever that the problem failed to specify what is the condition of the soil, or failed to specify that it is under local shear failure, the default solution is the ultimate bearing capacity equation for general shear failure. Okay, so for our updated given and for the different requirements, let's consider our first requirement, which is the allowable pressure. So for this allowable pressure, again, it is equal to the force all over the area, wherein we are provided with the mass again. Thus, for our mass, this must be multiplied to our gravitational acceleration g. And therefore, for our Q allowable, it is equal to 60,250 kilograms, our M, times G, 9.81 meters per square second, divided by our area. This is square, therefore that is 1 meter raised to 2. Our Q allowable is equal to 591,052.5 newtons per square meter. Therefore, if we will simplify this in kilonewtons, so Q allowable is equal to 591.053 kilonewtons per square meter or kilopascals. On the other hand, if we will consider the second requirement, which is the overburden pressure, Q is equal to gamma times Z or gamma times dF. So for our gamma, since the provided value is rho, to convert that to gamma, gamma is equal to rho times G. So Q therefore is equal to rho, that is 1,850, rho as the density, times G, 9.81. Then multiply that to df, which is 1 meter. And if we will simplify our value of gamma, that will be 18,148.5 newtons per cubic meter, or that is 18.1485 kilonewtons per cubic meter. So multiply that with the df, which is 1. Thus, our overburden pressure is 18.1485 kilonewtons per square meter or kilo pascals. Set aside the values and let us determine the third for letter C. So the ultimate bearing capacity for the square footing. So we have therefore QU as equal to 1.3 times C prime or cohesion times NC plus QNQ plus 0.4 B gamma and gamma. So for our bearing capacity factors, again, this is under general shear equation, thus table 2.1. So for table 2.1, our phi prime is 20. Thus, referring now, we have our NC as 17.69, our NQ as 7.44, and our N gamma as 3.64. So for our QU, we have 1.3 times C, 15 times NC, 17.69, plus our Q defined earlier, 18.1485 times NQ, 7.44, plus a factor of 0.4 square times B1 times gamma 18.1485, then times N gamma of 3.64. Thus, our QU is 506.404 kilonewtons per square meter or kilopascals. So before we continue, we need or in addition, we will identify what is the factor of safety value, knowing that we already determined QU and Q allowable. So for factor of safety, it is equal to the resisting QU, the generator of divided by the generator of failure, which is the allowable Q. QU is 506.404 divided by Q allowable 591.053. So by inspection alone, the denominator is greater than the numerator, thus Fs is lower than 1 and far lower than the value of our conservative factor of safety, which is 3, which means that it is unsafe. On the other hand, for requirement letter D, what is our ultimate bearing capacity for local shear failure, which is our QU prime. So for our QU prime, it is equal to 1.3 times C prime bar, so times NC prime plus QNQ prime plus 0.4 B gamma and gamma prime. So modify C, we have C prime bar as 2/3 of the original cohesion, thus the value is 10 kilopascals. Identifying the bearing capacity factors using table 2.2, this is for local shear failure. Our phi prime still is 20 and our NC is 11.85, our NQ is 3.88, and our N gamma prime is 1.12. Substitute in our equation, we have 1.3 times our C prime bar, which is 10 kilopascals, times NC 11.85, plus our value of Q 18.1485, times our NQ 3.88, then plus a factor 0.4 times B 1 meter, then times gamma 18.1485, and times N gamma of 1.12. Our QU prime is equal to 232.597 kilonewtons per square meter. Again, the soil for local shear or medium dense soil is weaker than that of the dense soil. Okay, so if we will determine our factor of safety with this value of QU, for the factor of safety, therefore, we have our resisting QU prime divided by the Q allowable. So our QU is 232.597 while our Q allowable is 591.053. Thus, our factor of safety is about 0.394 only, which is far lower than 1, and our conservative factor of safety, which is 3, which is unsafe. So if ever that your factor of safety is unsafe, how do we improve this or increase this value? So we can improve Fs by increasing the design area of the footing. So we will increase the dimension B by L. Meaning, if we increase the area, so the pressure distribution will be lower, which will be exposed directly to the soil. So if the condition again, so as a review of the soil is not noted, so the default equation is the general shear failure equation. So we have, therefore, this practice problem. And that's it for the soil bearing capacity for shallow foundations for Terzaghi bearing capacity equations under local shear failure. Take care and God bless.